MHD aerodyne combine various techniques. Among those that create a discharge with electrodes, we can mention spheroidal aerodyne. The principle of the spheroidal aerodyne is very simple. It's close to the cylindrical aerodyne. I just show how it could be featured with a model. Here you have a rotating magnet and metallic brush that feed cyclically the pairs of electrodes. We would expect that to get this, but unfortunately Doré's garage is too small to install both plasma experiment and hydraulics. And Mrs. Doré firmly refused to host a fluid mechanics laboratory in her kitchen. Spheroidal aerodyne model from plasma ionic can be built as the following. You need 3 coils with 120 degrees dephased currents in order to produce a rotating magnetic dipole coupled with synchronized pairs of diametrically opposed electrodes. Well, in the future we will achieve this experiment for low pressure gas and not for hydraulic because of the attitude of Mrs. Doré. Well, the wall converter was invented in 1958 by Mr. Way, and we rediscovered it during the 70s. This MHD configuration makes possible to get the electrodes as close as we want each other. On the other hand, it confines the interaction in the boundary layer. It is used in hypersonic craft cruising at a high altitude over 30 kilometers, where the low pressures give a good electrical connectivity. This explains the myth of Aurora, and the Russians had a similar project called Ajax. At very high altitude, a flying machine must cruise at hypersonic velocity, so they use MHD control inlet that makes possible to slow down the air with moderate heating using what is called now MHD bypass, so that ramjets can be used. Then the problem of the source of an energy is solved. But this kind of machine are uniquely designed for military purpose, so that the laboratory is not interested in. Let's go back to the disc-shaped aerodyne. The concept of MHD disc-shaped aerodyne was introduced by Jean-Pierre PETIT in 1975-1976 in 2 publications issued in the French Compte Rendu de l'Académie des Sciences de Paris. The first system is based on a set of spiral current streamers due to strong Hall effect, which produce centrifugal G-Bay force at the top of the machine, centripetal at the bottom. Here you have the disc-shaped aerodyne Formula 1 and its spiral streamers and system of quasi-radial forces at the top and at the bottom. If the magnetic field is created by a single equatorial coil, the glow discharge is pushed away. This confinement, as you saw, was solved. This is a paper presented in Korea. Jean-Christophe Doré is currently solving the problem of the stability of the current spiral pattern. Looking at such strange shape, one can be puzzled by the apparent anti-aerodynamic profile with sharp edges. Keep in mind that Lorentz force runs the flow and overcomes completely the inertial force in the case. The second family of models is based on the induction effect. If we produce an alternative dipolar axisymmetric magnetic field by equatorial coil, this field combined with induced current will produce radial Lorentz G-Bay forces that will be alternatively centrifugal and centripetal. If we combine this to with a synchronized control of the electrical conductivity nearby the wall, we can create a lift. Here you have this synchronization of the B field and ionization. It depends on the phase, on the two features. It corresponds to the use of centrifugal forces at the top and centripetal forces at the bottom. Of course, we have to use 3 synchronized coils to have wall confinement. This is the shape of the machine with the three coil. At the top there are features, and to get wall confinement the current must be synchronized but with opposite direction. This gives this magnetic pattern. And here in red we have features the confinement region where the plasma is kept. And of course, if we can modulate the ionization when we create the ionization at the bottom, on this slide in pink we have features the ionized gas, ionized air, so that if it corresponds to the step where the forces are centripetal, and in the other we have centrifugal forces. This last picture shows some attempt to modulate the ionization by hyperfrequency, but the shape of the disc-shaped machine produces immediately hyperfrequency electric arcs. This is beautiful, but it's not what we need. Another solution, a better solution that we intend to use consists to create this ionization by microwaves. So on the feature on the top and right, you have 2 cylinders that are waveguides, coaxial waveguides, with alternative injection of microwaves. And this picture at bottom explain how it works. Left, the central waveguide create ionization at the top of the model, and on the right, at the periphery, the waveguide create ionization at the bottom. So we could expect to have synchronized ionization and lift. Here I have presented mini-wave discharges in order to control the wall ionization. And this is a first experiment done in the Lambda laboratory in 2011 by Jean-Christophe Doré with some hundreds of ionizers. This is not completely homogeneous, but you can see side view that we have quite good ionization at the wall. The disc-shaped aerodyne with current streamers function in 2 temperature plasma with high Hall parameter, immediately greater than critical value. Well, we will have to face the Velikov instability problem. In the paper presented in Vilnius in 2008, we gave the computation of the parameter of the Velikov instability that are not so much known now. Here you have the critical value of the old parameter linked to the 2 expressions there corresponding to the value of the ionization. And here you have the growth rate of the instability. This growth rate is positive if the value of the old parameter is greater than the critical value. So these are the results published in Vilnius and also some years earlier. The Velikov instability is a plasma turbulence whose rise time is comparable to the ionization time and strongly enhanced by its nonlinear nature. It destroys completely the desired spiral pattern of the discharge. Here we manage, Jean-Christophe Doré built a low-pressure annular chamber with a cathode and glass which makes possible to take picture from the top. And here you can see the Velikov instability gives this kind of striation which is opposite to the passage of the electric current. And here the curves that correspond to the formula given earlier. Here you have the value of the critical value of the old parameters, which decrease and then is kept close to 2. This corresponds to the Coulomb-dominated plasma, when the electron-ions collisions dominate. And when the current density is increased, the electron temperature is increased too, the ionization is increased, the numbers of ions too, so that the collision frequency rises, and subsequently the old parameter falls, so that the conductivity becomes better. All this is combined and provides stable condition. We expected that. The local value of electrical conductivity corresponds to the following matrix. Left you have the electrical conductivity, and black the scalar conductivity. If we manage lanes in the chamber where the B field is weaker, the local value of the old parameter effect will rise the conductivity, so that the discharge will follow such lane, rise the electron temperature, rise the ionization and Coulomb collision frequency. The small magnets with opposite polarity with respect to the general B field, perpendicular to the plane of the figure, weaks its local value. And it works, as you can see. You can see the lane with weakened local value of the magnetic field, and you don't see anymore inhomogeneity. A full spiral pattern can be installed through fast sequential feeding of electrodes in order to prevent streamers interaction. The period of the sequence must be small with respect to the transit time of the air around the aerodyne. Back you have the spiral streamers and the expected flow. I have given a general view of our research. You see what we are searching for. Would like to check if turbulence and shock waves can be cancelled around disc-shaped machines. We have a certain step to cross. We have done some. We have kept the discharge close to the wall. We have mastered the Velikov instability. Now we have to control the spiral pattern of the flux. We have to master the modulated ionization in order to operate the induction aerodyne. Then we will evidence the flow with a border and evidence of the velocity field. And at the end, I don't know when, try the final experiments. Thanks.